Hello and welcome back to our show, Trigonometric Ratios of Any Angle, recording 1E in our series. Unit 2, Chapter 2, Trigonometry, Mathematics 2200. Focus on determining trigonometric ratios for quadrantal angles. Recall these relationships: sine theta equals y over r, cosine theta equals x over r, tan theta equals y over x. When we have a point on the terminal arm of theta. We'll use those relationships in a moment. Quadrantal angle, well, those are the benchmark angles we mentioned in earlier recordings, the ones that begin and end the quadrants, 0, 90, 180, 270, and 360 degrees. How do we find trigonometric ratios for quadrantal angles? Well, let's begin here. We have a terminal arm for a 0-degree angle. And because we don't know the length of the terminal arm, we'll call this point x. The y value has to be 0. So that means that x is the same as the r value. Because remember, it really represents the radius of a circle. Cosine of 0 degrees, therefore, x coordinate over the r value. But x and r are one and the same. So we really have x divided by x, which is equal to 1. The sine of 0 degrees. Y value over r value. But our y value in this case is 0. So 0 divided by r is going to be 0. Tan of 0 degrees. Y value over x value, which is 0 over x, which is going to be 0. Interestingly, because the 360-degree angle has the same terminal arm, these are the same values for the 360-degree angle. So we'll just mark those in as well. Moving along to our 90-degree angle. This time we have a coordinate, the y coordinate is unknown. The x coordinate has to be 0, so r equals y in this case. Cosine of 90 degrees, therefore, is equal to the x value over the r value, which is 0 over r, which is 0. The sine of 90 degrees is the y value over r, which is y over y, which is 1. The tan of 90 degrees is the y value over the x value, which is y over 0. But we have division by 0, which is undefined. So there's no value for the tan of 90 degrees. For the next one, I'll set it up a little bit. We have at the terminal arm going along the negative part of the x-axis, so we actually have a negative x value, but the r value is equal to positive x. That's important. So the cosine of 180 degrees is equal to, the x-coordinate is negative x, the r value is the same as positive x. So we wind up with negative 1 when we do the division. Negative x divided by x, negative 1. Sine of 180 degrees, the y value over r, but that's 0 divided by r, which is 0. And finally the tan of 90 degrees, or rather 180 degrees, is the y value over the x value, which is 0 over negative x, which is 0. Okay, our final quadrantal angle is the 270-degree angle. I want you to pause this recording for a moment and try to find these values for yourself. And here are the results you should have obtained. Cosine of 270 is 0, sine of 270 is negative 1, and the tan of 270 is undefined. Here's a little tip. We can get the same results if we use a simpler circle. of radius 1 unit. It's called the unit circle. So for example, at the 0 or 360 degree angle, the point on the terminal arm would be at 1, 0 because the radius is only equal to 1. So the cosine of 0 degrees according to this would be the x value over the r value, 1 over 1, which is 1. The sine of 0 degrees would equal 0, the y value over r, which is 0. The tan of 0 degrees would equal y over x, which is 0, divided by 1, which is 0. The interesting thing about the unit circle is that because we're always dividing by 1 here, this is x over 1, this is y over 1, the x-coordinate of the point will be our cosine for our angle, the y-coordinate will be our sine. You can remember them in alphabetical order. X-coordinate is cosine, y-coordinate is sine. Let's try it for the 90 degree angle. The cosine of 90 degrees, x-coordinate is 0, and the r value is 1, so that would be 0. The sine of 90 degrees is y-coordinate is 1, x-coordinate is, or the r value is 1. So we have 1 over 1, which is 1. So continuing on, the cosine of 180. Let's see if that works out. Cosine of 180 is negative, its x-coordinate is negative 1. The r value, though, is positive 1. And so we get negative 1. You can do the sine of 180 for yourself, and you should also do some practice in finding the tans. For example, if I go back to the 90 degree angle, the tan of 90 degrees is y-coordinate over x-coordinate 1 over 0, which is undefined because we're dividing by 0. In summary then, to determine the exact values of the trigonometric ratios for quadrantal angles without using technology, we use our relationships. Sine is y over r, cosine theta is x over r, tan is y over x, and set up diagrams such as the ones below.